Hello everyone and welcome to another video of Vivek Learns. In the last pep coding video that we had made, I had solved that balanced brackets question, right? So in this video we will start the next question of the stacks and queue. Yeah, we had solved this question. So let's try to solve the next question. And what is the next question that we have? This one, right? Next greater element. So we are given an array and we are required to find next greater element of the array. So let me take this input here. So the next greater element to the right, correct? So what will be the output? So let's say we have this array which is the output array or the result array. So which is the next greater element to the right? 5, right? So we'll print 5. Which is the next greater element to the right of 5? It is 9, right? So we'll type 9 here. Is there any greater element to the right of 9? Yes, it is 12. Then for 3 also it is 12. For 1 also it is 12. For 12 there is no element which is greater than 12 to the right. So we print -1. For 6, yes, there is a greater element to the right which is 8. For 7, no, for 8, is there any greater element to the right? No, right? So we print -1. For 7, like 7 is the uh, last element. So there is no element to the right of 7. So we just print -1. So that is how we'll get the result array, right? So how do we approach this problem? So let me first have this in a new file. Let's create a new file. So let me draw a line first representing some kind of base, and let me have this array here. So I have this array printed here. So I'll draw lines corresponding to these arrays. So I'll draw 2 here. So 2 will be something like this, correct? Then I draw 5, then 9, then I draw 3, right? So 3 will be in between 2 and 5, right? So let me draw 3. Yep. And we have 1. And then we also have 12. So 12 will be somewhere here. Yep. And then we have 6. So this is 5, right? So 1 greater than 5, it's almost here. So right from here. And we have 8. And this is 9, right? So it will be somewhere here. Then we also have 7. 7 will be in between. 7 will be in between 6 and 8, right? So somewhere here. Correct. Yeah. So this is 2. This is 5. My bad. This is 5. This is 9. This is 3. This is 1. This is 12. This is 6. This is 8. And then this is 7. Yep. So what do we do? How do we solve this problem? So one way we can do it is we can start the iteration from the right, correct? So what if we start the iteration from the right? What happens? We start the iteration from the right and we have to check if, like, the first and the most easy conclusion that we have is there is no element to the right of 7. So we'll have -1 here, right? It's as easy as that because there is no element. So we'll have to write -1 here. Which is the element which is there any element which is greater than 8 to the right of to the right? No, right? So what we can do is that we can have this element stored in a stack. So let's say I create a stack and let me draw some lines. Yep. So what I can do is that whichever element is smaller, I can have that. So let's say, let's consider we have 7 in the stack first, right? And then what we can do is that we can compare 8 with stack, stack.peak, right? So is 8 greater than 7? Yes, 8 is greater than 7, right? So what we can do is that we can pop this 7 and we can insert 8. So we insert 8, right? Then we go to the right and at the same time we fill the array with -1 because there is no element which is greater than 8, right? Because we have hit the we print -1. Let me write when we print. We print insert or add -1. We insert -1 when for two cases, right? First is when we for the rightmost element. And second is for the whenever we reach end of the stack. So for these two cases, we will print -1. So we have reached the end of the stack, then we insert -1 and then we add to the stack, right? So when do we add to the stack? So we add to the stack mm, when the array element is greater than peak, right? Then we add to the stack. Also, we pop the peak element. So before adding, we pop, right? Pop, and then we add, correct? So, yeah, yeah, that's it. And we'll have some more conclusions after this also. So we'll discuss those as we go along, right? Yeah. So then we go to the next element, 6. So We compare 6 with the element in the stack. We peek in the stack. 6. Is 6 greater than 8? No. So what happens is we insert we insert whatever is in the top of the is the peak of the stack here. So we insert 6, insert 8 into the array, and at the same time we insert 6 into the stack, right? When to add to the stack. So there are two conditions to be add. Mm, so let's say we describe those two conditions with array element greater than stack peak. So this is what we do when array element is greater than stack peak. Mm, so then stack peak, then what do we do? If array element is greater than stack peak, we add what do we do? Before we add to the stack, right? That's what we had written. But I just get confused. Yeah, we add to the stack. Before adding, we pop the element, right? And if stack peak is greater than the array element, then what do we do? We what do we do? We insert into the array the stack peak, and then at the same time, what else do we do? We insert or we push into the stack as well. Push what? Push array element. So this is the algorithm that we are going to follow. Yeah. So we'll insert 8 here because 8 is the peak. Insert insert to add the stack peak. Like insert the stack peak, and then we have to add in the push 6 here also. Then comes 12. So 12 is greater than 6. So what happens? 12 is greater than 6. So what do we do? Before adding, we need to pop the element. So we pop this. Then again, we compare 8. 8 is also greater than 12. So we pop this as well. Then we hit bottom of the stack. Or we reach the end of the stack. So what do? We print -1. So that is how we'll solve all these for the elements as well. Then comes and as soon as we enter -1, we enter the stack as well. So when we go to the next element 1, what do? We compare with the stack peak. So is 1 greater than 12? No, right? So what happens? 1 is inserted here and 12 is added here. 1 is pushed here. Pushed is the right word, right? Then we come to 3. So is 3 greater than 1? Yes, 3 is greater than 1. So it will pop 1 first. Then it will compare itself with 12. So is 12 greater than 3? No. So 12 will be inserted here. And then finally 3 will push itself in the stack. Right? And then we'll have 8. 8. So is 8 greater than 3? Yes. So it will pop it first. Then is 8 greater than 12? No. So what it will do? It will have 12 inserted in the array. Then it will have itself pushed into the stack. Then for 5, is 5 greater than 8? No, right? Then what happens is we insert 8 into the array and 5 is pushed into the stack. For the next element 2, we compare with 5. 2 is smaller than 5, right? So that's where we add 5 to the array and 2 to the stack. So this is how we'll try to solve this question, like 5, 8, 12, 12. Let's compare it. 5, 9, 12, 12. Oh, this is 9. My bad. This is 9. Yeah, so this will also become 9, right? 5, 9, 12, 12 minus 1, 8, then 2 times minus 1, right? Yes. So this is how we'll approach this problem. Let's try to code it now. So the statement will be next greater element to write, or the not the statement, the class name. We have created a class and we will need to take some inputs. So let me copy some code that we have already had to take inputs, right? Let me copy this code that we had. So this code, what it will do, it will take inputs, yep, and it will create an array, right? After this, what do? We create a stack of integers now. Stack is equals to new stack. Then what we can do is we can iterate over the array, right? We are iterating over this array, but we are iterating from the last arr dot length -1 to arr is greater than equal to 0, right? And we'll do I minus minus. So this is how we'll iterate from the last element to the 0th element. So once we start the iteration, what do we need to do? So before starting the iteration, we'll have to put the first element into the stack. So stack dot push is the right word, right? Push arr dot length -1. So we have pushed the first element, as well as we push an element into the array as well. Not push, we add an element to the array as well. Is equals to -1. Yeah. So what we have done now is where is my paint? We have inserted this -1 into the result array or the ARR. Oh, we'll have to create another array, right? How can we corrupt this array that we have? So let me create a new array, the same length. Right, and we'll have, yeah, -1 inserted in that array, right? So -1 is inserted there. Let's start the iteration now. So when we start the first iteration, what do? We compare. What do we compare? We compare whatever is in peak with whatever is the array element, arr of I. If arr of I is, let's say, which condition do we have first, right? If arr of I is, if array element is greater than, if array element is greater, then we push it, right? Stack dot peak. If array element is greater than stack dot peak, then what do? We insert stack dot push arr of I. Stack dot push arr of I. Right? If array element is greater, correct? Then stack dot peak. Yes, that's what we do. Right? Else, what we do? What if the element is and we have to insert into the array as well, right? So let's think about this first, and then think about the else part. If array element is greater than stack, we push. But before pushing, what do? We insert -1 or the peak element, right? No, we don't. We push. Before pushing, we pop, right? Stack dot pop. So if, let's say for this, arr of I is 7. Let's consider the second case actually, 8. If 8 is greater than 7, so it will pop 7 first and then it will insert itself. Correct? Yeah. Yeah. But we'll have to keep on doing this, right? So it's better that we have it in a while condition. What do you guys say? And we remove this. Hmm? If arr of I is greater than stack.peak, no, it's better that we have an if condition because it will go in an infinite loop, right? Mm, no, it won't, right? If arr of I is greater than, yeah, let's think about it afterwards. While or if, and then else. What is the scenario that we have? Else, what do we have? If it is smaller. So if it is smaller, then it's good, right? We directly insert that. But before inserting, we uh, uh, have it captured in result array. Result array of, mm, I like to have a variable here as well. Let's say I have index int result index. Or we can have the same index as well, right? Because we'll be inserting in the same order. So int result array of I is equals to stack dot peak. Then we do stack dot pop. The stack dot pop uh, return an integer. So it's better that we do stack dot pop here itself. Right, and what do we do after this? Hmm. So if it is greater, then we pop. If it is less, then we mm, no, then we peek, right? Sorry. And then we push into the array. Stack dot push into the array ARR of I. Yes. So either ways we have to push to the array, so we can have this statement out of the if else condition. But let's think about the if condition now more seriously. So if it is less, we are clear, right? What do we do if it is less? We get that element first and have it inserted in the array. Then we push ourselves, like the element pushes itself into the stack. This is clear. Then what happens if it is greater? So if it is greater, then we'll have to keep on checking, right? So if it is greater, then what happens? Let's see. Let's say for 12. For 12, what condition did we have? Let's check once more. For 12, we had, oops, I think it is exhausted now. The control Z and control Y are exhausted. Okay, so for 12, let's consider which elements we'll have in the array. So we had -1 here, and then we'll have 8 inserted here, as well as we'll have 6 inserted here. And then comes 12. So what 12 will do? While ARR of I is greater or ARR of I is less than the stack dot peak, yeah, while ARR of array is greater than stack dot peak, or a stack dot peak is not empty. Till then we'll perform this activity. And what is the activity that we'll perform? Mm, I'll write this afterwards. Let's have if here, then we can have while loop inside it. What do you guys think? Yeah, I think that will be a better approach so that we don't miss the count, like the index also. So while ARR of I is greater than stack dot peak, we'll keep popping the elements, right? And yeah, that's what we do. And once we'll find an element which is, once we find an element or we hit the end of the stack, so that condition we'll have to right here, or we hit the end of the stack dot peak, uh, stack dot pop, right? So we can consider it here. If stack dot is empty, then we insert -1, push, uh, where where is that array that we had? Result array of I is -1. Hmm. So what else condition that we had? Yeah, so this is the only condition that we have. If stack is empty, else what we do? We insert the element which is peak, right? Stack dot peak, correct. Yeah, so we can have this outside. Yeah, so what do we do if the element in array, let's say this element 12 is greater than um it is greater than stack dot peak, which is 6 for now. Then as long as it is greater, we keep popping. So we remove 6 and then we remove 8. Then we hit, then we come out of this loop. Once we come out of this loop, but we'll have to have a condition here. If stack is empty and stack is not empty, right? If stack is empty, we don't do stack dot peak, right? Yes. So if stack is empty, then we have hit the bottom of the stack. So we insert -1, right? Else, what do we do? Mm, if we had a scenario like 1, if we had this scenario, let me erase these two numbers and we have this scenario where I had 12 and 1. I had 12 and 1 here, and then 3 came. So 3 compared with 1 and it popped 1. Then it has to insert the stack dot peak, like the next literal element 2 3 is 12. So what we have done here in the else is we have inserted the stack dot peak, and then we push to the array at last in any case, in the if condition as well as in the else condition. Alright, so what happens in the else condition? In the else condition we just insert into the array. Yeah, so I think this might work. Let's try to run it once. So I'll consider this array 1 2 3 4 5 6 7 8 9. So we have 9 elements, right? 2 5 9 3 1. 9 elements, 2 5 9 3 1. The one we had 12. After 12, what did we have? 6 8 7 6 8 7. Oh, and blunder, we did not print any output. So at last we'll print the result array, right? Or how do we get to know what is the output? Let me rerun it once. Yes, 9 2 5. What was it? 2 5 9 3 1 3 1 12, and then 6 8 7, right? 6 8 7. But I want to consider the first condition. So what do we do for the first condition? Array stack dot is empty, stack dot peak. So 7 will be compared with 7, right? And then it will go to else part, and then it will insert stack dot peak. So yeah, so we'll have to do stack dot peak is empty, then we'll have to insert -1. Or how do we handle the first condition? That's what I'm thinking, to have it in a more optimized way. So in the stack we'll have 7 first. So one thing we can do is that we can start iterating from you know, um, arr dot length minus 2, right? And so to do that, we'll have to also insert into the array minus 1, but that seems fine. Yeah, let's do that. Yeah, we have already inserted into the array minus 1, right? So let's start the iteration from arr minus 2, or let's run it once. 9 2 5 2 5. I keep forgetting it. 2 5 9 3 1 12 6 8 7. Yeah, let's compare this output with the one we have here. 5 9 12 12 12 minus 1 8 minus 1 minus 1. Yeah, so this is how we have solved the next greater element to the right question. So I hope you guys understood this question. It was a lengthy one, but if you practice it 1 or 2 times and draw the diagrams on your notebooks and practice it, you will get a more better understanding of this. Yeah, so that's all for this video. See you guys in the next one. Thank you.